Flow rate problems. In the medical field, patients are often nourished intravenously through an IV. The number of drops applied through an IV per minute depends upon the type of IV equipment used. For our application examples, we will use the following general drop factor. Drop factor, number of drops per milliliter. Some examples of common drop factors include 10 drops per milliliter, 12 drops per milliliter, and 15 drops per milliliter. We can use these common drop factors to convert units from milliliters to drops in a flow rate problem. So it's just a conversion problem, really. A conversion involving rates. Example 2. Find the flow rate for the given IV, assuming a drop factor of 15 drops per milliliter, and round your answer to the nearest whole number. So the given is that 1,500 milliliters, we want to give 1,500 milliliters to the patient in 4 hours. And we need to know how many drops per minute we want to give to the patient. Solution. We'll use the conversion factors 15 drops per milliliter and that there's 60 minutes in 1 hour. So we're starting with milliliters and hours, and we want to get drops per minute. So we need to go from milliliters to drops and hours to minutes. So our original measurement is 1,500 milliliters in 4 hours. So if we take 1,500 milliliters in 4 hours and multiply it by the conversion factors to take milliliters to drops and hours to minutes, then we can do our necessary cancellations and our multiplying and simplifying to get to an answer with drops per minute. So here we have original measurement. We set up the conversion factor so that the old units, milliliters, will cancel. So we put the 1 milliliter on the bottom here. And then we set up this conversion factor here for time so that the old units of hours will cancel. So we have hours on the bottom here, so we put hours on the top here so that we can cancel our hours and cancel our milliliters. So then when we multiply, we'll have 1,500 times 15 times 1, which is 22,500, and only drops left on the top because milliliters and hours will cancel. And then on the bottom we have 4 times 1 times 60, which is 240, with only minutes left on the bottom because milliliters and hour units cancel. So then we have this fraction here, and if we simplify this, we end up with 22,500 divided by 240, which is 94 drops per minute. So 1,500 milliliters can be administered in 4 hours if we administer at a rate of 94 drops per minute. Example 3. Find the length of time an IV should be administered. Assume a drop factor of 10 drops per milliliter and give your answer in hours and express part of an hour as a fraction. So last time we were finding how many drops to administer per minute. Now we want to know how many hours would it take to administer medicine given a 10 drop per milliliter drop factor. And also being told this information. We have 2.85 liters that we want to give to the patient, and the rate that we're going to, now we know the rate instead of finding it, and the rate we want to use is 50 drops per minute. We want to know how many hours is it going to take to give 2.85 liters to the patient. Solution. We'll use the conversion factors 1 liter equals 1,000 milliliters, and 10 drops equals 1 milliliter, our drop factor, and 1 minute equals 50 drops, and 1 hour equals 60 minutes. So we start with our original measurement of 2.85 liters, and since we want to get ultimately milliliters because that's what's in our drop factor is milliliters, we convert our liters to milliliters with this conversion factor. We set it up so that the liter units will cancel, and then we'll have milliliters when we multiply here, and then we can multiply by the conversion factor that tells us drops per milliliter. This converts us from milliliters to drops, and then we can go from drops to minutes with the one that says we get 50 drops per 1 minute, and then we can go from minutes to hours knowing that there's 60 minutes in 1 hour. So we're just doing a bunch of conversions to take liters to hours. So then here's the original measurement, set up so liters cancel, multiply by the factor to go from milliliters to drops, and set that up so that the milliliter units cancel, then multiply by the conversion factor to go from drops to minutes, and set it up so that the drops units will cancel, and then multiply by the conversion factor to go from minutes to hours, and set it up so that the minutes units will cancel. So then, if we have it all set up correctly, we can then just multiply and be left with just hours because all the other units are going to cancel. So we'll have on the top, we'll have 2.85 times 1,000 times 10 times 1 times 1 divided by 50 times 60, which ultimately leads to 9.5 hours. So it would take 9.5 hours to administer 2.85 liters at a rate of 50 drops per minute and a drop factor of 10 drops per milliliter.